In science, sometimes we deal with really, 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 really big numbers. For example, the mass of the Earth is this many kilograms. That's a lot of zeros. Also, we can deal with really, 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 really small things. For example, the mass of an electron. The mass of an electron is a really, 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 really small number. It's this many kilograms. Look at all of these zeros after the decimal place before you get to your first digit. This is really annoying and cumbersome to write this, plus it's easy to lose track of the zeros. So there's a method used in math and in science to write really, really, really big numbers or really, really small numbers called scientific notation. So for example, the mass of the Earth is instead written as 5.97 times 10 to the 24th power, and the mass of the electron is written as 9.11 times 10 to the negative 31st power. So let's do a little bit of practice of writing these on paper and also understanding how to do scientific notation in spreadsheets and calculators. Let's take a number that's really big and write it in scientific notation. The population of the United States right now is about 340 million. To write 340 million in scientific notation, first, let's find the decimal place. It's not explicitly written, but we know that this is the ones place and the decimal point is right here. Okay. Next, what I'm going to do is I'm going to move the decimal point over to the left as many spaces as it takes to get a number that's between greater than 1 and less than 10. So I'm going to move it to the ones place, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, okay? And so now my decimal point is going to go there. I have a number that's greater than 1 and less than 10, so I'm going to rewrite that. And then by moving the decimal place over, it's a trick that we're doing that's actually showing how many times we're multiplying this number by 10. And so to get the exponent for this 10, what we'll do is we'll count how many times we moved it over. So 1, 2, 3, 4, 5, 6, 7, 8. And so 340 million is equal to 3.4 times 10 to the 8th people. To go in the opposite direction from scientific notation to a big number, let's take a look at the estimated population of China. 1.412 times 10 to the 9th. I'm going to reverse the procedure. I'm going to rewrite the number at the beginning of scientific notation. So 1.412. And then I'm going to move the decimal place over to the right for as many digits as there are for this exponent here. So this is 10 to the 9th. So I'm going to move the decimal place 9 places to the right. So 4, 5, 6, 7, 8, 9. Okay, and for all these blank spots in here, I'm going to put zeros in there. So 1. Okay, so to rewrite this in normal number notation, it's 1, 4, 1, 2, 0, 0, 0, 0, 0, 0. I put an unusually large space there for no reason. Put commas in there if you want. So this is 1,412,000,000 people estimated in China. Let's take a look at writing really small numbers in scientific notation. The width of human hair is 0.000075 meters. It can be a little bit bigger, a little bit wider, a little bit thinner, but this is a good average size of human hair width. To write this number in scientific notation, I'm going to find where the decimal point is, which is right here. And I'm going to count the number of spaces that I move it to the right until I get a number that's greater than 1 but less than 10. So here we go. 1, 2, 3, 4, 5. Okay, right now I'm at 0.75. I'm not there yet. 6. 7.5 is greater than 1, less than 10. So this is going to be the first part of my scientific notation. Moving this decimal is a trick for multiplying times 10 to the negative first, or 1/10. If you're unaware, negative exponents are the same thing as multiplying by 1/10. So I'll rewrite in a moment to show you what that means. But we've moved this back 1, 2, 3, 4, 5, 6 spots. And the width of human hair in scientific notation is 7.5 times 10 to the negative 6 meters. Like I said, negative exponents is the same thing as the exponent of the fraction. And so this is like doing 1/10 to the 6th power and then multiplying it times 7.5. But this is the conventional way of doing it. Technically, there's nothing wrong with this, but this is not convention. Convention is to use negative exponents when working with really, really small numbers. We'll reverse the process to do the approximate radius of a carbon atom going from scientific notation to a normal decimal number. So we'll take our number and our decimal. We'll rewrite that. Okay. I'm going to write it all the way over here on the right because we're going to move to the left to make our decimal number. Okay. And then we're going to move the decimal point to the left as many times as we have in the exponent of scientific notation. 13 times. So zeros we're going to add here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the decimal goes there now. And then we fill this in with all these zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So that's the 13 spots. We move the decimal, gives us 12 zeros in front of the 7. If we were to rewrite this, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros, and then that 7 gives us the 13th spot that we moved it. And so this is how you would write the radius, approximate radius of a carbon atom in regular notation.
Writing numbers in scientific notation is good for paper, 1.5 times 10 to the 13th power, for example. But doing it in a calculator or a spreadsheet can lead to some problems if you write it that way. If you type it in a certain way, and particularly if you do division with numbers in scientific notation, you can lose track of the order of operations and as a result get an incorrect answer. So there's a way that calculators and spreadsheets use to keep track of scientific notation that doesn't have an issue with order of operations. So there is a way to do it on your cell phone calculator, but we're not even going to consider that because you can't use your cell phone calculator on the exam, so why bother learning it for class? You need to learn how to use it on a calculator. So you can do a number in scientific notation. There's a couple ways to enter this. You could do 1.5 times 10 to the power of, let's say, 7. Okay, and you get a number like that, or 1.5 times 10 to the power of 7. Okay, this gives you, what is that, 15 million. That a surefire way to make sure that your exponent is correct, particularly in calculations, there is a capital letter E that is used in calculators and spreadsheets. And so we'll do 1.5. For this graphing calculator here, you do second comma, and it gives you E. E is computer speak for times 10 to the power of something. As you can see, you get the same answer. Same thing for this scientific calculator, 1.5 capital E7, and you get the same answer. Okay.
A note about scientific notation in spreadsheets. Once again, you can write it the long way, but if you do it in a spreadsheet, if you just write in the number 1.5 times 10, little caret symbol to the 7th, okay, it actually doesn't recognize it as a number. It actually thinks it's text, and so it doesn't write it out as a number. Like we were doing with calculations in Google Sheets for our data collection, you have to put an equal sign in front of this for it to recognize that you're trying to do scientific notation. I could do the opposite and go for a really small number. Okay. But the thing that I want us to use when we're doing stuff in a calculator is to use this capital letter E. So you'll do equals 1.5 E, capital E, times 7, or 7 is the times 10 to the power of. So a reminder that E stands for times 10 to the power of 7. So this gives you the same exact number. If we do the same thing, it's 1.5 E negative 7. Okay, and that's the exact same way of doing it.